The cause of curing cystic fibrosis is bigger than any of you, he used to say. No wonder then, when those seminal articles were published about the identification of the CF gene in 1989, the list of the authors numbered more than a dozen, and more than 100 centers had contributed samples for the work. De Saint-Ignace had taught us that we were all in this together, that collaboration was the single best and fastest path to the relief that the families sought, and that we wanted so desperately to give to them. By the time those articles appeared, I'd been at Case Western Reserve for several years, with a cystic fibrosis team that epitomized de Saint-Ignace's principles. Researchers and clinicians, nurses and respiratory therapists, we all worked together with the families to treat the patient's symptoms and to learn better ways to defeat the disease altogether. Today, I have the privilege of leading the academic medical enterprise that is our School of Medicine. U.S. News ranks us among the top 25 medical schools in the nation. So many students want to come here that we can accept only 3 out of every 100 who apply. These students graduate to intern in the very best hospitals in the country. We received more than $270 million of federal research funds this year, and several of our departments rank in the top 10 in the nation for NIH funding. All of these statistics are impressive, but the true measure of our influence rests really in one single category: the difference that we make for people. By what and who we teach, what we learn about the stuff of human life, and how our research and education combine to improve our patients' lives. Though we have had great success in this area, I have to tell you today it is not enough. For all that we do, for all that we've achieved, too many people still live in pain, too many battle disability and illness every day, and too many, far too many, succumb prematurely. In some cases, the roots of our frustration stem directly from the improbable complexity of the human body, and we just really need to know more how to decide how to intervene. But some of our frustrations come from the choices that we make as a nation, a community, and as leaders of healthcare organizations in Northeast Ohio. We can do more, and by coming together, we will. Now, before I discuss some of these solutions, let me assure you that we do have the right talent right here in Cleveland to succeed. Consider some of the highlights of our history. Our faculty have been creative educators since 1909, when Flexner named Western Reserve University as one of only 3 medical curricula in the U.S. to be worthy of emulation. In the early 1950s, the faculty at the school developed a landmark new approach to teaching medical students, one that was quickly adopted by schools around the country. Nobel Prize winner Frederick Robbins was attracted to this school. He was one of 3 scientists responsible for breakthroughs that led to the polio vaccine, and he was attracted to serve as our dean from 1966 until 1980. Other Case Western Reserve faculty developed the first heart-lung machine for use during open-heart surgery, performed the first surgeries for coronary artery disease, discovered how staph infections are transmitted, a finding that led to required scrubs in the neonatal intensive care units. Lots of achievements. But in addition to Dr. Robbins' prize, graduates and faculty of our School of Medicine have won 7 other Nobel Awards. Their work advanced creation of drugs to stop cancer, development of magnetic resonance imaging, studies to understand the responsiveness of blood vessels to disease, and the discovery of insulin. Today, the School of Medicine continues that proud legacy. 3 years ago, for example, we launched Western Reserve II, a revolutionary curriculum designed to prepare future physicians for lifelong learning. 5 years ago, to meet the need for clinical researchers, together with the Cleveland Clinic, we launched the Lerner College of Medicine, a track within the Case Western Reserve University School of Medicine. We are home to the Case Comprehensive Cancer Center, one of only 40 programs around the country to earn this designation of excellence from the National Cancer Institute. This collaboration among the university, the Cleveland Clinic, and university hospitals, led by Dr. Stan Gerson, involves 300 scientists and attracts more than $150 million in research support every year. More recently, we launched the Center for Stem Cell and Regenerative Medicine, another multi-institutional effort that includes the clinic, UH, Ohio State, Athersys, a local biopharmaceutical company, and a CWRU spin-off, Arteriosite. It has drawn more than $100 million to the region, and it involves 120 researchers. One of Athersys' products for the treatment of cardiovascular disease and strokes was named the 2008 Innovation of the Year by a global healthcare research organization. The prospects for improving lives through stem cells and other biotechnologies are truly inspiring. They have emerged through decades of dogged scientific inquiry and have led to impressive progress. Consider just a few facts. At the beginning of the 20th century, the average life expectancy in the United States was 47 years. At the close of the century, it was 77. Over the past 30 years, the death rates from heart disease have declined by 63%, and those from stroke by 70%. The new drugs, treatments, and lifestyle advice developed over the past 3 decades have translated to more than 500,000 fewer deaths from heart attacks alone every year. 500,000. Now, that translates to several million people who still have a father, still have a mother, or a brother, or a friend, or a wife. Think of your own loved ones for a moment. Numbers can't begin to quantify the true human impact of these gains. At the dawn of the 21st century now, however, we now stand on the brink of a whole new era of medical discovery, which has emerged through the work of thousands of scientists on countless fronts. Chief among them, however, has been our increasing understanding of the chemical and biologic roots of precisely who and what we are. Nearly 2 decades ago, the NIH joined with our Department of Energy and several international partners to launch the Human Genome Project, an initiative to identify all 3 billion letters or base pairs that combine to form the complete set of DNA in the human body. Now, DNA, as you may recall from your science classes, is in essence the blueprint for how we develop, boy or girl, brown eyes or blue, tall or short, and so much more. The Human Genome Project, which included researchers from our own School of Medicine, completed its work in 2003. Along the way, the time it takes to identify a gene responsible for disease in a person fell from years to days. The success of the project allows us to go even deeper to the submolecular level, which in turn allows us to develop treatments that are more targeted, more effective, and less likely to produce side effects. One of the lessons of the Human Genome Project is, for example, that genes do not act in isolation. They and our health are impacted by environment, our behavior, and other elements of the human body. As a result, entire new fields have emerged: systems of biology, proteomics, bioinformatics. What does all this mean? To put it in simplest terms, every day we grow closer to tailoring treatments to each individual patient. We can engineer already and produce naturally occurring molecules to attack ailments or turn on or off biological switches in our own bodies. We can determine the detailed structure of naturally occurring molecules and then systematically engineer alterations into them to improve their properties. We can use biomarkers, essentially genetic or chemical elements that vary from person to personalize treatments. Should you take more or less of a particular pharmaceutical? Should we start treatment earlier or wait a bit? If we don't treat you at all, will you still be okay?